Okay, guys, so I am going to make this video for you to try to teach you Chapter 8, Section 3. This is the title of it. If you're taking notes and you need to write it down, feel free to pause your video. Okay. Likewise, with this location principle, I'll let you read it. Feel free to pause the video if you need to write it down, but let me show you what this means. If you had a function where this is point A and this is point B, and if I have a graph where this is the function evaluated at A and this is the function evaluated at B, you can see that because this location is negative on the y-axis and this location is positive on the y-axis, that there has to be a zero somewhere in between. It is impossible to go from negative to positive without crossing over zero. This will become very important in just a couple of minutes. Okay, we're also learning about critical points today. There are a couple different kinds. There's maximums, which you have seen before, right? If this graph is increasing, it reaches a top point called a maximum, and then it turns back around. Likewise, you could be going from left to right and decreasing, hit a minimum, and then turn back around. Okay, so this would be a maximum, this would be a minimum. It's definitely possible to have more than one in a single picture. Okay, this right here, this point way up here at the top, this is called the absolute maximum, right? It's the highest point on this entire picture. You're never going to find another higher point. This point is called a relative maximum. Relative max, because it's higher than the points immediately to the left and the right of it. It's not the highest point in the whole picture. It's just higher than these points near it. This point would be considered a relative minimum. Because again, it's not the lowest point. This doesn't have an absolute minimum, but it does have a relative minimum because it's just lower than the points immediately to the left and right of it. All right, this one, again, if you need to write this down and have some understanding of it, pause your video and read it in greater detail. I'm going to use all these tools on the next slide. So this is a very large synthetic division chart. Okay, it's already been filled in. These were all the numbers that we tried to fill in. Here's all the work across the middle, and these are the remainders, right? So these are all the X's that we tried. These are all the Y's that came out. So if we're trying to figure out where the zeros are, one of them is obvious right here. This ordered pair of 1, 0 is one of the zeros. If you plotted that point on a graph, it would be right on the x-axis. Okay, but there are two more that are a little harder to see, and they require the location principle. One of them is right here. Okay, it's in between. And you can kind of see that this is a negative number and this is a positive number, which means somewhere in between there is a zero. I don't know exactly where it is except to say that it's between -2 and -1. So if you said, hey, where's that zero? You'd say, oh, it's between -2 and -1. There's another one. It's right here. Right? And again, the reason there's one right there is because this is negative and this is positive, and somewhere in between any negative and any positive, there's a zero. If I asked you, hey, where's that zero located? You would say between 3 and 4. Okay, so you locate your zeros over here in the Y column, but you state where they are over here in the X column. You are going to be making charts like this today, really, really big charts. All right, now you may be asking, well, how do I know how big to make it? How do I know where to stop? And that's where the upper and the lower bounds come into play. So for this one, if you're finding the upper bound, you're looking for a row where there is all positives all the way across. Right here is your upper bound. Right? And again, if you look at every single number that's in this row, all those numbers are positive. positive 4, positive 1, positive 1, positive 2, positive 12. This is considered the upper bound. You're not going to find any more zeros past there. All right, and lower bounds have alternating signs all the way across. So this row right here is the lower bound. Lower bound. And that's because the signs alternate. -2, +1, -5, +8, -12. When they alternate, that means you're not going to find any more zeros. Your zeros should all be somewhere between the lower and the upper bound. Okay, so with all that information, let's see if we can actually do this example. We're going to make a big XY chart, which is synthetic division. We're going to see if we can find the zeros, and we're going to actually draw a picture of it. Okay, so here we go. Big XY chart. I'm going to have a 1, a 2, a -3, and a -5. I really have no idea where to start, so I'm going to put 0 sort of here in the middle, and I'm going to do synthetic division fairly quickly and ask myself, did I find a 0? No, I didn't. So let's start working our way out. We're going to kind of try a positive number, and then we'll try a negative number, and then we'll try another positive number, and we'll try another negative number until we find the zeros. So let me try 1. And if I'm doing synthetic division a little bit fast, it's only because I did it earlier, and I'm trying to fit all of this into a quick lesson. All right, so I'm looking here. There's no change of sign. I haven't found a 0. So let me try a negative number. When I put -1, 1, -4, -1, still haven't found a 0, right? I have no change of sign over here or any zeros. Let me try number 2. So here's 1, 4, 5, and 5. Again, I have this pre-written out. You can double check my synthetic division. Here is a 0. It changes from negative to positive, so I have a 0 somewhere between 1 and 2. I also, if I look really close, have the upper bound right here. All those numbers, all the way across, they're all positive, which means I can stop looking in this direction. I will not find another 0. So let's just look in the negative. Let me put in -2. 1, 0, -3, 1. All right, so check it out. I found another 0, right? There's a change of sign in this column from positive to negative, which means I have a 0 somewhere between -2 and -1. But this thing is supposed to have 3 zeros. I only have 2, and I haven't found the lower bound, so I need to keep going. Let's try -3. Let's see, with -3, I get 1, -1, 0, -5. Okay, cool. There's another 0, right? A change of sign between -5 and 1. So I have my third 0 between -3 and -2. And I also have the lower bound. Here it is, negative, positive, negative, positive, negative. If you're wondering why that 0 is considered to be positive, I need you to go back to that slide, right? Rewind the video and find the last bullet on that slide. You'll see this is the lower bound. So I have found all 3 zeros. We're going to graph this because what I have here is a very beautifully written out XY chart. Okay, so let me move that to the side. Hopefully you can still see it. And let's draw a really nice picture. So all I have to do is plot these points. -3, -5, -2, 1, -1, -1, 0, -5, 1, 2, 3, 4, 5, 1, -5, and 2, 5, 1, 2, 1, 2, 3, 4. Okay, so as I'm connecting these dots in a smooth flowing curve from left to right, again, smooth flowing curve, this is what that picture looks like. All right, I'm gonna have to pause this and make a part 2 to get my second example in.